This episode of the Unbuild It podcast is brought to you by Huber Engineered Woods, makers of Advantech subfloor assembly products. Engineered with long-lasting strength, moisture resistance, and nail-holding power, Advantech subfloor is the brand builders trust for quality subfloor. Combine the strength and moisture resistance of Advantech panels with the bonding power of Advantech subfloor adhesive for a solid, even subfloor assembly, perfect for a variety of floor applications. Follow along with builders and their Bringing Their A-Game campaign on the Advantech Subflooring YouTube channel, at Huberwood on Instagram, and their new website. Visit advantechagame.com. Thank you, Huber Engineered Woods.
Welcome, Unbuild It podcast members, for episode 6. Today, me and the boys, Jake and Peter, we take a deep dive, even deeper into the pool with water management. We're going to talk about everything water management here. We're going to eliminate the thought of talking about rain screens today, just because that's a topic unto itself, and that podcast is going to be following up on this one very shortly. But let's talk about water and how we deal with it. As an architect, my first plan is to eliminate the threat, right? If we have water, and water is the biggest problem on our buildings, the first thing I should do is try and get rid of as much water as I possibly can before it becomes a problem for my buildings, right? So how do I do that? Well, first thing, it's just like when we go outside, what do? We put on a big umbrella or a big hat with a brim, nice big fisherman's hat, and keep that.
I got
water.
this really good visual right now of you with an umbrella and a really big hat. Buddy.
That's my Steve Gloucester fisherman picture.
Nice.
Oh, I was picturing Kentucky Derby lady escorting her husband.
That's not funny, Jake. I know funny, and that's not funny. But
okay, continue. Sorry.
No, that's okay. But seriously, on a serious note, thanks, Jake. We as an architect, the first way to deal with water is to eliminate the risk. So you'll notice on a lot of my buildings, those that know me or have seen me present, it's not uncommon to find a 24, 30-inch overhang on some of my buildings and push that water away and keep it off of the wall. Joe from Building Science would always say, all windows leak, and my contention is only the ones that I let see water. If I don't let it see water, then it doesn't have the potential to leak. And a lot of people have rules of thumb. One of the rules of thumb that I like to use is the distance from the head of the window to the soffit versus the length of the soffit. Typically, at a minimum, I'd like to see those numbers be a 1-to-1 ratio, but most of the time when I'm designing, I strive for at least a 1.5 to 1, meaning that the soffit is at least 1.5 times as long as the distance of the head of the window to the soffit. To me, that provides
a
nice
2-story houses, Steve?
Well, 2-story houses, it's a totally different program because you do have those set of windows down below. But I do have a couple projects where even in 2-story buildings, there's lower roofs or the way you can cut up a building, or simply add some awnings. Or different other
porch roof,
something like that. There's, one of the beauties of living here in New England, I can drive around and it's not rocket science. I can go to some houses that are 80, 100 years old that have little eyebrows that just push out from the wall over the windows. And the whole intention there was to eliminate the risk and just push the water out, let it drip in front of the window and drip down. Or even if it dripped and got blown back on the window because of wind, it's going to get blown onto the pane of glass. It's not going to get blown onto the wall above it. And at that point, you've pretty much eliminated the risk also, right? So,
that's... Back in those days, Steve, they couldn't rely on sticky stuff, so they had to rely on design.
100 years ago, water management was all about gravity, right?
Yeah, it was never caulking or tape.
Yeah, none of that stuff. And the stuff that did get into the wall, obviously, the houses probably didn't have insulation or have issues, so you had a significant amount of energy that could dry out that wall system so that you really wouldn't even have a potential problem even if it did get wet. But in today's world, with these very complicated wall assemblies, and some of the insulations are pretty sensitive. I mean, you put 12 inches of cellulose into a wall, and you don't put time and effort and dollars and budget into a proper window installation, that could be a hell of a problem, because the only way you're going to find out that you do have a problem there is when you drive up one day and the window's laying out on the lawn and there's a hole in the wall, because there's no way to really identify that there was a problem there, because the wall was so darn thick that it literally rotted away in front of your eyes. You just never had the ability to see it. So,
Steve, on like 2 and 3 stack gable ends, it's not uncommon here in Brattleboro to walk around and see little visor roofs that break up the gable into one or more sections, because even if you have a 12-inch rake overhang, it's got to protect 2 or 3 stories. That's not going to work. So breaking up that gable into parts is another way of design to protect the windows, right?
Yeah, I mean that's a huge role. It's funny because both of you guys bring up the multi-story wall, window or door in a wall. I remember when we were at Building Science Corporation, I remember a specific conversation on what is the largest callback. I want to say it was Town and Country Homes in Chicago area. But one of them had their biggest callback, or their most expensive callback, was sliding glass doors and 2-story walls. For one, they were a challenge to flash properly. But the biggest problem is that the problem wasn't just the leak. Chances are that sliding glass door was by a breakfast nook or dining area or something, so it had hardwood floor. So now that leak comes in, it buckles the floor. So now you're not only dealing with that problem, you're replacing and fixing that floor and probably refinishing the floor on the whole first floor for that reason. So that one problem becomes exponentially, very dramatic problem. So,
and a lot of 2-story walkouts with sliding glass doors, and you were at Building Science Corporation in the late 90s or mid 90s to mid 2000s. That's the heyday of poorly built vinyl sliding patio doors as well.
Yeah, I mean exactly. And the desire was at an all-time high and the quality was at an all-time low. So you were inversely proportional to success.
And so your perspective of trying to answer things from a water standpoint in the design phase of construction is actually the exact same thing that I do in design phase of construction. Literally, the first thing I look at on a set of plans before I even look at address or square footage of the house is, okay, well, let's turn to the page where I can see roof lines and I can see the elevations and get a sense of where's the water going to go. Am I going to look at this set of plans and go, yeah, unless they're willing to change something, this isn't a house for me because the risk is too high? I had I had a potential consulting client send me a set of plans, and it is a 3-story house with no overhangs whatsoever, and the fiber cement siding is nailed right to the Tyvek on the plans. And I said, all of this is fixable, but we have to take water way more serious before you start building a house like this than what your architect is. So the architect has to be on board, or you have to be willing to, redraw this yourself, because no one involved in this project appears to have thought about water. And that's a scary thing.
Yeah, I mean, those, I'm often, you can hear me say, Mother Nature always wins, right? She has a perfect record. She might forfeit a battle, but she wins the war all the time. So when you think you can roll the dice, you might be able to make it past your warranty period. But if you're, the builder of the caliber that I think you should be, then you should probably be concerned about your house long after the warranty period.
Yeah.
I think that's
even in our market. I'm in Columbia, Missouri, and even in our first meetings with clients, I don't beat around the bush, and I say, well, you may get a 5-year warranty on the house, but the state of repose for the state of Missouri is 10 years. So if something's gone wrong because we did something inherently wrong, if we didn't follow manufacturer's instructions, or we have structural issues or things like that caused from poor construction, this is a effectively a 10-year warranty on those sorts of things. And I don't know a single spec builder in my market that A, knows that the state of repose is 10 years, unless they've been sued for it, or B, cares because they don't think that clients are going to figure that out. They don't think that it's going to come back on them. And 10 years is a long time. You know, it's not a long time in the course of a. Sorry, you guys can't see Steve trying to hold up a note so that we can talk about something, but we can't read his notes, so that's why I'm laughing.
So before we go to Steve, Jake, you know, you have your businesses based on a reputation of your dad, and then you. There was a guy at the research center named Bob Schmidt. He was in his 80s when he was working with us on innovation in residential building, and his attitude was, I don't want the house to last 10 years. I gotta have that house last a lifetime because the reason I have market share is because people know that's a Bob Schmidt home. So he was always super interested in durability because he said, I want my buildings to be as durable as my reputation. Exactly.
Yep.
Yeah.
It makes perfect sense. I mean, if you look at my business, there is no advertising. I mean, yes, you could call Instagram or this or, you know, Build Show Network advertising, but it's not paid advertising. So people are finding me organically because of the reputation.
Yeah. And, you know, I and even though I advocate for very large overhangs, I remember years ago sitting in a gentleman from SGH, noted building scientist, was giving a lecture, and part of it was on roofs and roof overhangs, and he did a whole bunch of studies, etc. And he came up with this idea or concept that, you know, 8 to 10 inches, 12 inches, somewhere in that range, let's say 8 to 12 inches, was the best roof overhang scenario. And the reason he said that was that while 8 or 10, 12 inches isn't 24, it still kept water off. But the beauty of the shorter soffit is that the maintenance of it and the care for it is, you know, would last 100, 200 years. And it would be a lot easier than trying to care for a 30-inch soffit, let's say. So
just from a like overhang sag perspective?
Overhang sag, or, you know, there's a lot of people. I mean, I can drive around here and take some photos, and there's people that, you know, maybe extend the life of the shingles an extra year or two, and you get a hole in and you can start seeing the soffit rotting from the inside. And what people don't realize is that water management problems, and Pete, I'm sure you can talk for days on this, but it's once they hit failure, the failure is kind of exponentially grown. It's not even linear. It's crazy that, you know, you add a little water, it rots a little, then it adds a little bit more water, it starts rotting a lot more, and before you know it, you have major problems that you can't deal with there. You know?
Yeah, it's by the time you get some expression of bulk water damage, it's like the tip of the iceberg. Often it's, you know, a lot's been going on for months or years that you don't even know about. Steve, I would say too that, you know, in terms of the stress that the overhang sees, if the overhang is, you know, tied in structurally to the rest of the roof assembly, yeah, I can see that, you know, particularly with solid stone rafters or even with trusses, that you'd get some translation of what's going on with the rest of the roof to the overhang. But, you know, we advocate, of course, that we build flush boxes and then stick on stuff afterwards like overhangs. So, you know, they're independent in terms of how they're constructed. They're not tied to the rest of the roof system. So maybe that's another reason that if you're going to do bigger overhangs, even more important that you do ladder build-outs, because you don't want them to take the stress of what's going on with the roof.
Yeah,
or find a way to have a flat soffit instead of exposed rafter tails. You know, having that bird box, that flat soffit that goes back, then you're creating that little triangle of framework there. That's not going anywhere. I think that East Coast thing of the exposed rafter tails isn't as popular in my market, so it doesn't, that, you know, sagging doesn't come into effect very often here.
I mean, you still get some of the sag. I can go and look at some of these older houses. You get sagged, and that's just because the framing members there, you know, to go out 24, 26 inches, they're they're not strong enough. And it's not that they're failing, they just simply bend or creep, just like old wood does when it's put under a loading condition. And
that also brings up a good, like, no building should be considered to be maintenance free either.
Oh yeah, most definitely. And so I am torn with his comment, because while I hear what he's saying, I'm not quite convinced. I can certainly drive through a lot of houses in some of these old New England towns and see, beautiful four squares that are 100, 150 years old that have 24-inch overhangs where the wall and soffit still look in great condition, and it's all because of the size of that soffit.
So isn't there a really big portion of this country, though, that's going to be like rolling their eyes at us talking about water because they just don't see much of it? Do we have different water management techniques when we have really low rainfall or precipitation compared to when we do?
I think it's like anything, right? That I consider water management somewhat a load, right? And that in some cases the load is different, right? Like Minnesota's snow load is certainly different than Virginia's, right? Mm-hmm. So the rain load would be, I would consider, different also. That here in Massachusetts or Miami or Houston, we probably all have a different rain load than, say, Albuquerque, right? Now, Albuquerque gets one or two pretty harsh storms a year, and they're probably equal to anything the other three of us get. It's just we get them more frequently and, a lot more of them during the year than Albuquerque does. So it is one of those games. And, when I designed houses down there in New Mexico, yeah, we still worried about walls. We still had kick-out flashings, and we had really good overhangs. Those were part of the design there, because the beauty of it, Peter, is in the hot, sunny climates that you get the rain, a little less frequently, like Albuquerque or, say, Tucson. You have a lot of sun. So now you're using the overhangs as a shading device or for something else. So you get the byproduct of good water management by virtue of having good shading devices.
Yeah, I'm thinking too that, back when we were building Science Corporation, Joe made a big distinction between 20 inches or less or 20 inches or more, where you could face seal your cladding systems if you had less than 20 inches of rain a year. And, if you had more than 20, you were going to have to do drained rough openings, that you would not have your primary water management occur out at the exterior cladding. It happens behind that at the WRB tied to the penetration flashings. I mean,
is it some sort of sliding scale then, Peter? Is it I get very little rain, so I'm less concerned. I get more rain, so I'm more concerned. I have no overhang, so I'm the most concerned. I have, only a southwest facing in my market. This is most of the weather. Southwest facing, only exposed, no overhang walls. So I'm the most concerned. Like, are we just talking about we should be concerned at all points? Because there isn't anywhere. That's a bad way to say it. There are very few places that get no rain.
Well, I think it's even more complicated than that, Jake, because you could take that sliding scale that you just talked about and then introduce different components, right? So if you look at a windrows for a certain area, and if you get most of your rain out of the northeast, okay, now it's the question is, it's the northeast side of the house versus the southeast, so I get more rain. It's a 2-story wall versus a 1-story wall, so I get more rain. It's a sliding glass door versus a fixed window, so I get more rain or more risk. So I think, the point here is...
The contractor's got a drinking problem, so...
Yeah, but I think, you just need to kind of take every case by case. When I do a project, I literally, I design it. I do a SketchUp model, and a lot of architects like SketchUp because they get to draw pretty pictures, and I get to illustrate that for the clients and share that. And yes, they love it. But the SketchUp model is more. I
like your SketchUp drawings, by the way.
Thank you. And don't try and be nice to me. This is see, now you got me. Now I'm totally lost. I don't know what to do.
Now you're confused.
Yeah, when people are totally nice to me, I'm totally lost. See, I never have that problem with Peter. But where the hell was I going with this, Jake?
Well,
Jesus.
while you're trying to regain your footing, Steve, and not a concrete footing, but your footing. There is a hinge point, Jake, and that's face sealed is one technique for managing bulk water, and drained rough openings is another. And so the big difference too to me is that if you face seal something, then you're exposing your sealants to ultraviolet light. You're exposing them to a lot more water, more temperature change, but you can inspect and repair and replace, right? So it's a bit of a double-edged sword that if we put all that sticky stuff on the outside, we're really depending on keeping the water out, but there's less of it. But we then take these key components and make them susceptible to really big stresses like ultraviolet light, temperature, and more water.
Yeah,
And so that brings me to my favorite conversation that I think I've ever had with a rep. They were a rep from a sealant company, one that everyone would know. And he said, this is what you should use on your hardy siding. It's color matched, and it's going to last a long time. And then you don't have to worry about water. And I said, okay, how long does it last? And he said, well, that depends. And I said, okay, so I'm supposed to tell my client that they need to just know when it's needs to be replaced, or do you have a maintenance and repair schedule for me? And he said, well, it's a case-by-case basis, depends on which side of the house, depends on... And I said, okay, so then what is the recommended inspection time period? How often am I telling my clients that, or how often should it be inspected to ensure that we're not going to have a failure that we're unaware of? He said, well, probably twice a year. Okay, so you're telling me when I build a house for someone who's in their late 60s, early 70s, that's 2 stories, or a ranch with a walkout, that they should be on an extension ladder twice a year, inspecting every window and every inside and outside corner? And he just kind of looked at me, and I said, how about we find a way to eliminate your product on the outside of a house? How about I find a way to lap my siding or to make my framing around my windows so that I don't have to rely on your product, and I don't even have to have it involved at all? And of course he didn't like that, but that to me is the answer. And so I'm not a fan of that face sealed system that you're talking about.
Yeah, and I know you brought it up, Peter, but I'm not. Water management is management. I'm not a big fan of face sealed. It goes back to my question of what happens when water gets on the backside. Because if I install 30 windows in a house and I face seal them all, chances are that 30 windows has 4 edges to it, so that's 120 edges, right? Yeah, I did the math right there. That's 120. 100. I did it in my head too. I kept my shoes on, and that's 120 edges that I got to get right. And chances of getting all those right and having the northeast side or whatever, the heavy rain side, just barreling down on that scares the hell out of me. I don't.
Well, this takes me back to the time when we were talking to Peter Pfeiffer, and he said, oh man, my buildings get soaking wet in areas where we have 5 inches of rain a year. It's the bloody irrigation systems that are watering the house rather than the plants that I have to defend against.
That's on at 3 o'clock in the morning and no one knows is spraying the side of the house because they're not awake at that time.
Yeah, I remember we had a building investigation in Las Vegas that was irrigation system. It was sprinkler oriented. That was the problem. But, you brought up another good point that I wanted, I was talking about different orientations, stories, whether it's a window or door. But the other thing I think that plays a major role in this is how much energy is the wall holding back or, keeping out? Meaning putting a wall in, say, a 12-inch wall of cellulose versus a 2x4 wall in Texas with an unfaced bat in it versus a 2x4 wall filled with closed cell foam. Those are all different energy capacities and abilities to dry inside that wall. And, I think the water, you could take the house that has the unfaced bat and pretty much drench it, and it would have the ability to dry pretty free. But you put that same amount of water in the other two, and I think you have a larger problem.
Yep.
Yeah, but in a hot, dry climate, I'm not going to be putting 12 inches of insulation in the wall. So, I think that you're right. There is a relationship between wetting and drying, but it does both of those change by climate as well. I'm not a big fan of face sealing systems either, but I mainly work in parts of the country where I am seeing way more than 20 inches of rain a year. I'm working with 2 clients right now that are in places that have a lot less water exposure, and we are scaling back water management, but they're willing to handle almost all of it with design, using the approach of, well, I don't get much water to begin with, but if I can keep that water off the building, then I'm going to be a lot less interested. And this bleeds into the next conversation about rain screen systems, because, do we need rain screen systems in climates that have less than 20 inches a year?
Don't jump episodes ahead, though.
No, we're not going to go ahead. But you know what? We should take the time to move further down the wall, right? So we put a good roof on this. We try and keep as much risk away, or eliminate as much risk as possible by putting this roof overhang. Now, that doesn't necessarily mean the water is gone. It just means we displace that water. And the thought I was thinking of earlier, Jake, was me building SketchUp models, that I build them to get the pretty pictures and illustrate to the client, but SketchUp is a really great way for me to build the model, spin it around, and just ask myself, is there any problems in this roof? Are there any places where I should be concerned or worried? Am I pushing water? Because
where's the water going to go?
Yeah, because it's not only the roof overhang with roofs. I mean, we see it all the time up here in New England, Peter. People have these A-frames that are 2 feet away from each other. So you have 80 feet of house that drains to 3 feet of gutter. And it's like, or it's pushing water down this major valley, and then they have a dormer on the opposite side of the wall, and the people want to know why there's mold growing in their daughter's bedroom, and why, they have an ice dam in that valley all winter long. Well, it could be that the dormer's a foot out of that valley, right?
Yeah.
So water management is definitely tied to some poor design also, or the infamous, I know the minute I say it you'll recognize the photo, but I have that nice classic photo of a gabled roof up against the wall with a window literally centered on the drip line of the roof that didn't have a gutter and didn't have a kickout flashing. It's like, why don't we just staple a garden hose to the roof, turn it on, and hope the window doesn't leak?
Yeah.
Right?
So I took some flack about the pandas being not cute comment the other day. I think that I can also continue that by saying A-frames are the most disgusting side foray that American architecture took that I can think of on a regular, like that late 70s to mid 80s in my market of people building A-frames. And what is it about someone who builds an A-frame that they need to build 7 of them in a row and turn them into rentals in my market? That was the thing in our area too. That just I get it. You solve a lot of problems.
Jake,
by just making
the
whole
modern
house a
teepee.
roof.
It's the modern teepee. You really need to get with the times.
Okay, you're going to take the controversial side of A-frames are good.
A-frames are exceptionally good.
And they're really beautiful too.
Thank you, Peter, for the backup there.
Peter, do you live in an A-frame?
No, but I do live in a four-gabled gambrel, which has a lot of water management challenges.
And there's a lot of other people that think the gambrel is also.
Hey, Jake, speaking of water management.
That's the ironic thing. I can't stand gambrels. I think they're about ugly, but I live in one.
Speaking of water management, Jake, I always tell people Brattleboro is one of the few places where I see ground-coupled ice dams.
I am very happy that I don't have to deal with an icicle that comes from my roof that couples down to the ground.
Well, it's sort of like geology above ground.
Yeah. Okay, so we were headed down the wall.
We're heading down the wall, and we're going to skip over the wall because they come back on the next episode, and we're going to take a really deep dive into rain screens because it's probably one of my favorite topics and opportunities. But so that water that drips off the roof, it's got to go somewhere. The easy solution is gutters to downspouts to something either underground
to daylight,
to across the surface to sloped ground away from the house. It gets back to that down and out that we talked about on the previous episode, that everything should be using gravity to its advantage and then moving it away at the first opportunity, whether it's the ground, a gutter, whatever. I've done ground gutters. With ground gutters, nothing more than taking a 6-inch perforated pipe, putting it in a round barrel of stone, trench around the house centered on the drip line
Filter
of the
fabric.
roof, and wrapping it in filter fabric and basically just putting a little canal underground and whisking that water away from around there. But I think also, as you know, in the last, I would say 10 or 15 years, a lot of my work is subgrade. Let's finish that basement. I mean, I know people in New England up here, they love it. They call it free space, which is baffling to me, but we do call it. They call it free space, and they want to go down there and they finish it. And I got to tell you guys, I have some projects where finishing a basement is not. I'm finishing some of these basements for what Jake probably builds a new house for down in Missouri. And you know, when you get into bar, fitness center, pool table room, rec room with dual TVs, so their son and his buddies can play Call of Duty and have multiple 75-inch screens to play the game, so they can pick the right weapon without having to switch the screen. It's crazy. And
that sounded like you knew a little bit too much about that, Steve.
It seems like there's a specific client he's talking about, too.
you guys, just because I'm the host today doesn't mean let's bully on Steve, okay? That's just,
Well, it doesn't have anything to do with you being the host.
That's just not nice.
Okay, so that water management at ground level, our contract or our scope of work that we create has the scope of work has a backfill procedure that includes a clay cap 5 inches down from final grade that has a 6% grade away from the house, which when I put that in, our excavator just went, so just make it slope away from the house. And I was like, yes, but we're going to put some clay aside. We're going to we're going to lay that clay in, and then our final grade with topsoil will cover that clay. And that 5 inches of topsoil will be enough for us to be able to grow things we want. But that clay is a little,
Jake, the classic maneuver here is, and I see it all the time. People, you put the foundation in, they backfill the foundation. Guess where it sinks? Right along the foundation. Around the foundation. So you get a negative slope towards the foundation. The excavator guy is gone. The machine is gone. And what does he say? Oh, that's the landscaper. The landscaper will do that. So the landscaper comes, guess what he does? He dumps 18 inches of bark mulch there and slopes it so it looks like it's sloping away from the house, but all he's done is create this ground gutter and shuttling
reservoir
every ounce of water towards that foundation wall. I see it all the time.
So then our warranty actually goes far enough to address the idea that if you don't maintain gutters, if you don't maintain planting, if you don't maintain grading, that's not my problem, because we're going to make sure that we're leaving it in a place where I don't have to worry about the neighbors dumping water onto your foundation. We're going to take care of that while we're here. But it's the second that you hire a landscaper or you bring in your brother-in-law to help you plant a row of bushes, and the first thing he does is move a bunch of dirt and then plop it where it stops the drainage, the natural drainage that we've created around the house. So we're taking it so serious that we have a procedure for how things are going to get backfilled, but then we also have it addressed in the warranty, and it's something that I show to clients and talk to them about it.
You know what else is a nice little tidbit of advice? And you probably don't have to do it on every site, but I fell into it, and now it's become pretty much standard procedure for me. If I go to a site, and as an architect, a lot of the sites these days are far more challenging than they've ever been, because the flat pasture lots just don't exist anymore.
They're gone.
So you're putting in this house. So a couple of years ago, I was doing this house on the backside of a ski resort, and it was a pretty steep mountain. They were down the hill. The lot was about almost 200 feet long, or 400 feet long, but it dropped almost 200 feet in elevation.
That's not a lot. That's a cliffside.
It was literally like you could have had a double walkout on the one side of the house. But the interesting thing was, I was at the job site and got caught in a downpour, and the site was such that the top of the site was at a road. You go across the road, and then there was a steep, probably half a mile, 3/4 of a mile hill there. That was all rock. The amount of water that came down that hill, across the road, and down their site was absolutely incredible. And I would have never known that if I wasn't there on a rainy day. So now if I'm starting a new house or something and it's going to be a bad day, I take the opportunity to walk that job site or at least drive by it and say, is there anything, that I should be a little bit more concerned about here than what I see on a sunny day? And just, take note of that, because the amount of water and what we did there was not only did we put the perimeter drain down at the footing, it was a 10-foot concrete wall on the high side. I ended up putting a 8-inch perforated pipe about 3-4 feet down in the ground and about 3 feet away from the building, and had the building slope away from it, buried in the stone. But the idea was to take as much water that I could away from the building before it even got to the footing drain, and take that around the building.
It's funny, I'm for the Keene State course that I'm teaching on building performance assessment, I just got done doing some slides for tomorrow's class on the 3 loads, which are the site water load, managing that, the water that comes off the building, that's the building load, and then the third one is where's the groundwater table. And if you don't defend against all 3 or know what the threat level is from all 3, you could do a good job on the building, but you're really pushing your luck if it's a project that needs a lot of site water management. And the tough one is the groundwater, because getting good information on where the groundwater table is not easy for a lot of sites.
No.
Not unless somebody just built next door.
Well, the article that I wrote on Green Building
challenge.
Advisor for this was the best resource is find the oldest excavator in town. He's dug a hole somewhere near your site in order to.
That's actually 100% true. My excavator is in his. I hope he doesn't listen. I'm assuming he is in his mid to late 80s, and I kid you not. We're looking at a project that Steve and I have going, and I said, "Are you familiar with the subdivision?" He said, "Yeah, we dug 3 of those houses."
Yep.
Okay, what is it like? And he said, well, we dug these 3 and they were like this, but we also dug one on a property next door and it was like this. And if you follow that vein north, you can get to, and he knew exactly what the limestone track looked like through this part of the county. And I was just like, that's like, he might not be the best excavator in town, but his knowledge base and his experience and his time in the business is invaluable.
Well, it all depends on how you measure the best, right?
Well, my undergraduate degree is in agronomy, and when you do a soil profile, we have soil maps.
You can breathe underwater?
Did I say that agronomy too fast? When you do a soil profile, it goes down 60 inches. So you can get a map of the entire United States online for soil sampling that's been done like every half of an acre in most areas. But when you get down below 60 inches, which is where the foundation's going to be, we don't have the same kind of tables for what happens to the water load below that.
Yeah, and you never know.
Mighty important.
A few years ago, I did a very large house for a couple that bought a piece of property, not knowing what the water table was. Guess what? We dug a ditch, 30 inches standing water, and they wanted a full basement. We pulled the house 6 feet out of the ground on that project.
You got to build a boat hull at that point.
I've done that too.
And then you have to look at changing factors. Things like fracking could affect water table as well. Now, you hope that that's temporary, but you don't know for sure.
No, not at all. I mean, it's, underground water. And the thing is, when I'm doing these basements and working and people say, oh, do I really need that sump pump? Or in a lot of cases, my personal house here, I have 2 sump pumps. And the second sump pump is actually, I set it in the bucket. It's at the same elevation, but I set the second one on a brick and it drains out to my driveway. So if I drive up in my driveway and I see water getting pumped out across it, I know that the second sump pump has been engaged and that the first one is failing because the water has risen beyond the first one. And it's happened a couple times.
It's the definition of belt and suspenders.
And I had to change out that first sump pump. But
so, Steve, in the winter, do you rent out that sloped, iced driveway to the kids in the neighborhood so that they can really get a zippity-doo-dah?
Well, I just attach a flexible pipe to the outlet, and that's what fills my skating rink.
Yeah, there you go. Yeah. I like
Is the
that.
skating rink the cul-de-sac at the end of your driveway?
So, we've been talking about all this water coming down, and of course we got to talk about the water coming up, because that groundwater table, or when we get capillary continuity, that's going to be water that can move against the force of gravity rather than with it. So those capillary breaks, wherever we have porous material, they're kind of hidden in the code, and I can't say I've found a whole lot of buildings that have problems because of capillary water rise, but I have found some.
Yeah. So this, Pete, I'm going down the controversial road here, because I have done capillary breaks between footings and walls, but I'm not quite convinced that it's an issue. I mean, if we excavate and we're in 2 feet of standing water, then it probably would be an issue. But if we excavate and there's a little water and we have to pump it out, I don't know. I think that's an area that you kind of have to question. There is tons of pushback because the footing guys don't want to put their forms in any goop, right? And if you say, well, okay, we'll use a membrane, well, then the guys putting the membrane down say, well, how am I supposed to put this membrane down? We have a number 5 bar coming out of the concrete every 24 inches, and how do I deal with that?
What a bunch of whiners.
Well,
Holy smokes.
Well, I hear you.
I might be on the same page with him, though, Pete.
This is
Hey,
The
this is,
density
You've
of
got
the concrete.
one opportunity. You just got done talking about all these people that want to finish their basements.
No, I know.
There's no way I'm going to take that risk. Go ahead, put the capillary break in, because you'll never get another opportunity to
All
put
right,
it
so
in.
let me ask you this. Then. If I was doing a new basement and I thought there might be a potential water problem, how do you feel about me trading off the capillary break for a drain tile on the inside of the footing and on the outside of the footing, and going to 2 sump
Connected.
pumps?
So you put me in this position of a trade-off. I would say, why not do both? I mean, you got one opportunity to improve the water performance of that below-grade assembly. I just don't see where, and we've talked about this before too, Steve, because a water stop is a vertical divider between the footing and the cold joint formed by the foundation wall above it. And that's even more difficult to put in than a capillary break. But again, if I particularly have a client that's going to be doing like a bowling alley in the basement, or
I
shuffleboard.
investigated one of those. I mean, it was probably maybe 8 or 9 years now, but the people had a 16-foot deep basement. The walls were 12 inches thick, and yes, their underground theater room was experiencing wet floors.
Yeah, yikes.
And when the builder called me in and we walked around the back, I said, "You're not going to like how we find out what's going on." And he said, "Please don't tell me we have to excavate this." And fortunately for him, he wasn't the builder of the house. He was the person doing some work for those homeowners that just bought this house and realized
He was the problem solver.
And he was the problem solver. But I have pictures of us with a 16-foot excavation about 8 feet wide around the back of this house that was probably close to 160 linear feet of foundation wall. And here's
so maybe that capillary break is cheaper than.
well, this
what
wasn't
we're
a
talking about.
capillary. The capillary break probably would have prolonged the problem, but the real problem was when we got down there. The sad thing was there was filter fabric, there was stone, there was a drain tile. The drain tile was filled with silt and crap.
Because there was no continuity in the filter fabric.
There wasn't no continuity in anything. It was like all 3 of those materials were there, but it was like somebody.
Into the
Yeah,
trench.
it was like someone backed up a pickup truck, threw them in the hole to say, "Oh, did you bury a pipe in filter fabric?" Oh yeah, it's all in there.
That's because it sucks working down in that hole.
It's all in
sucks.
there. But it wasn't there, and it didn't matter where we cut that pipe. I have pictures. I cut that drain tile probably in a half dozen locations, and it was solid pretty much everywhere.
So Steve, the last thing we're going to lobby for is, yes, even the best design of that perimeter footing drain can result in it getting accumulated silt in there. So what are we going to do to be able to maintain that over time?
Right. Well, and then that brings
I'm
up.
not done. It was a rhetorical question. I'm not done.
Yeah, I'm ignoring you. I'm ignoring
Put
you.
in a clean out, just like you do for your sewer system. I want the clean out, Steve. I want that big frickin' ugly vinyl pipe sticking right out next to the front
And so
entrance.
we'll go back to my scope of work. My scope of work says no more than 50 feet of pipe, 50 feet of pipe without a clean out.
Yeah,
Because I want to be able to access it.
You guys
And
are
I
killing
know
me.
what Steve's going to say.
You guys are killing me because usually I advocate
Put
for.
that in your pipe and smoke
Well,
it,
I
buddy.
advocate for performance over aesthetics, or a performance with agreed aesthetics. How's that? And you guys are pushing pure performance here because there's no way I want some fat, ugly pipe sticking out of the ground just so you guys can go and run your little snake through it every 6 months to clean out a drain tile.
Well, we're capping it
heresy.
and we're cutting
This
it
is
at grade
heresy.
level so you can.
So.
We're cutting it at grade level so you can mow over it, and we're most of the time we're painting it mulch color if it's in the
Yeah,
mulch
so you
bed
took
or
a
whatever.
fat, ugly pipe and now it's just ugly.
Yeah, thank you.
But so I guess if I were to do that.
So what's your solution?
So work
then?
with us.
If I were to do that, I think I would probably take a couple prominent locations, like center it on a window, find a corner, something like that, bring the pipe up, and probably cap it, but keep the cap about 10, 12 inches below grade. So that way there I can come later, put a big friggin' rock or something on top of it to mark the spot. And if you need to get into that system and snake it or clean it out, flush it, whatever, you move the rock, you dig down 8 inches, you unscrew the cap, and now you have access to it.
I think what we ought to do is at the top of the pipe, etch in your initials and your cell phone number so that you can be the one to
And
come clean it out.
So that they can call him and ask him
Yeah,
why
call
he buried
Steve.
it.
Call Steve.
You guys are beautiful. Here I am trying to make the world a better place, and this is what I got to deal with.
I feel like we have to have that reminder conversation to the listeners that we actually do like each other.
Hey, you know what? You know what I did see? It was in an
Speaking of
article.
liking each other.
It was in an article in JLC not too long ago that I thought was pretty neat. I'm still not quite convinced, but I might do this on an upcoming job. On the outside of the foundation, they put in like a 24-inch pipe that was like 7 feet tall, and they put the sump pump outside.
No crap.
Yeah, so it had like a little
I have one outside at my current house.
Yeah, so it had like a little manhole cover, but then you had access to the perimeter drains through this
I have
24.
never heard of that. So how do you protect it in cold weather? Is it somehow?
Well, it's down like 7 feet, so
Capped.
so it's
And
capped.
it's down at.
Oh, that is. I'd love to see that. Can you get pictures of that?
Yeah, I'll
I'd
dig
love
a
to
hole
see
and
that.
take pictures of it for you.
I have one at my house. I actually have 2 sump pumps. I live in a 60s ranch that has
Of course
some
you do.
foundation cracking and very minor
And you
water
have an
over the years.
outside. Your sump pump is outside the building.
Yep, it's outside
Wow.
the window that I'm sitting next to right now.
Literally thinking outside the box.
It's just sitting on the lawn, Peter. It's not like plugged in or anything.
Yes.
It's just
It fell
just
off my
outside.
truck bed the other day, and
Peter,
it's just been out there.
Peter,
for
he
6
lives in
months.
Missouri, so it's just when he says something's outside, it means it's outside in the lawn. It's like, yeah, I got 5.
It's violating.
Hey, sorry
It's
for
violating my rule of three times. So I have a mental rule with my guys and like my family. If you set something down and you walk past it 3 times without thinking, oh, I need to take care of that, that's where that thing lives. That's where that thing's going to stay from here on until someone else takes care of it because you've already designated that as that's the spot. So like there's a bucket that's been sitting outside of my shop for 6 months that somebody left there, and I left it just to see if the person that left it there picked it up, and they haven't because they've walked past it more than 3 times. It's no longer their concern.
You better
So
hope nobody kicks
that's-
that bucket.
That's my rule of 3 times. You cannot walk past that a 3rd time.
All right.
You have to
Shut
pick
up,
it up.
Jake. We're done. I got to close this
Okay.
out. I'm the host today, so you have to listen to me.
I'm not sure if that's how that works, but go
Well,
ahead.
that's what you said at the beginning. You said you're in charge, Steve. You manage the time. So I'm managing the time. So shut up. So that being said, we're going to join us on episode 7 because we'll carry on this conversation, but we'll get into my favorite topic of rain screens. But before we go, why don't we clean up a little bit of business, and then we have a personal request for Peter. But Jake, why don't you take care of some of that personal business for us?
Yeah, so in episode 2, we spent quite a bit of time complaining about appraisers and their inability to value the energy efficiency or durability aspects of homes. And I have to say thank you to Ryan, and I think it's Renard from River Rock Builders in Little Rock, Arkansas. He sent us a message, and he told a specific story. I won't get into the details of his story, but they were able to significantly increase the appraisal of a home, a LEED certified home that they were working on, through the HERS rating system and Fannie Mae's energy efficiency addendum. And we looked it up. It's Form 820.06. And so you can claim solar, you can claim renewables, and you can claim energy efficiency items. And they were able to get like an extra $90,000 out of an appraisal just based off of those items alone and filling out the correct form. So that's going to be part of my regular repertoire now, because very often we're building houses in the 40s and 50s for a home energy rating, and we have to get one of those rating scores for the city anyway. So it's basically filling out one more form could work wonders for me. So I have to really say thank you, Ryan, for sending that in.
Yeah, kudos to Arkansas. Woohoo!
Yeah. He also included, if you think the energy efficiency building game is slow in the uptake in Central Missouri, try building in Central Arkansas is how he ended his. So I think he feels the pain that we were talking about anyway. So.
But then we didn't. We had one more, right?
Yeah, Peter.
Yeah, I'll jump in. So we got I don't have the guy's name, Jake. Maybe you can help me with that. But a fellow who asked us about where's the best place to locate that air barrier or air control layer, and we're going to spend more time on this in a subsequent episode. But I just thought I'd throw in my 2 cents to say there's 3 different locations you could have that air control layer. Exterior interstitial, which is in the cavity, or on the interior. My favorite on the outside, because it's easiest to keep it continuous and it prevents wind washing at corners. But given a choice between its location and its continuity, I'm going to worry way, way more about getting it continuous than in what plane of the wall it's located.
Yeah, and as a teaser,
that's my story, and I'm sticking to it.
Well, I'm not listening, but as a teaser, my opinion is I really don't care where it is. I care about how vertical it is and how much it doesn't change plane. The more coplanar I can make that air barrier, the happier I am. So stay tuned. In an upcoming episode, we'll dive really deep into that, and Peter and I will get into it.
Alrighty.
And that question actually came from Mike, Northwest Aero Barrier.
Oh,
so
right. Mark,
he also says
Mike,
says
right.
It's Mike, Peter.
He also says
Mike.
hi,
Yeah.
Pete.
Sorry, Mike.
That's
yeah.
okay.
Mike Argelan, right? Was his last name.
Yeah, Bend, Oregon.
Thanks, Mike.
Wow.
Hey, my turn, Steve, right?
It's all you, buddy. Close it out for us.
Nicole Basic, today is your birthday. Happy birthday to you. Happy birthday to you. Happy birthday, dear Nicole. Happy birthday to you.
That was excellent, Peter. Hey, I want to shout out too. Being a Marine, my daughter's husband is in the Army, and believe it or not, him and his guys listen to the podcast overseas, and they love it. They love it.
Cool.
So kudos to the Army.
Thank you for your service, guys.
Thank you, Eric, for your service. Great son-in-law. Very proud of you. You and Nicole take care. Happy birthday, sweetie. Gentlemen, that's it for today. We're done. Finally, I can go take some Advil and get over this and move on.
Episode 6. Join us for episode 7, where we take that deep dive into rainscreens.
It's dive, not drive.
Sorry.
All right. Well,
Okay.
Later, listeners.